Okay, we're going to begin chapter 3, which is called numerically summarizing the data. I mentioned in a couple of videos that chapter 3 is, I believe, where the real math begins. So we're going to be doing, things with formulas, things in the calculator, and chapters 1 and 2 are nice. They're essential, but chapter 3 I feel is where the math begins here. So in section 3.1, we're going to talk about measures of central tendency. And central tendency is just kind of fancy words for three things, which are mean, median, and mode. Okay, so those are the three things that we're going to be talking about there. Now, in everyday language, the word average really stands for arithmetic mean. Okay, and the arithmetic mean of a variable is the number of that is a number that summarizes all of the data values by adding up all the observations and then dividing by the number of observations. So when we compute an average, the data must be quantitative, okay, since we're adding and dividing, okay. Let x1, x2, x3, all the way up to x sub capital N be a group of capital N numbers in a population. Then the population mean, which we're going to call mu, is given by mu equals x sub 1 plus x sub 2 plus x sub 3 plus x sub, all the way up to x sub capital N divided by capital N. Okay, the symbol mu is a Greek letter there. Okay, so when you compute an average, you're going to add up all the numbers and then divide by the total. Another definition, let x1, x2, x3, all the way up to x sub little n be a group of little n numbers in a sample. Okay, then the sample mean, represented by x bar, is given by x bar equals x sub 1 plus x sub 2 plus x sub 3 plus all the way up to x sub little n divided by little n. Okay, now when we compute a mean, these two formulas are pretty much the same. Okay, the only change is that hey, right here I'm using a capital N and right here I'm using a small n. Okay, by the way, whenever we have a population and a formula is given, it's going to be in terms of a capital N. Okay, whenever we have a sample and a formula is given, then it's going to be in terms of a little n. Okay, just as a note. And make sure that you get the symbols correct on this, okay, for whatever we do. So one of the things that we're going to have to pay attention to is whether we have a population or a sample. Okay, and I think your book does an excellent job at telling you what's a population versus what's a sample. Okay. If you're ever not told, and there will be some times when you do that, you always assume that the data is coming from a population. Okay, and for a mean, it's not going to matter, right? Because it's just getting the right symbol there. Okay. Another definition there. Order the numbers in a data set from smallest to largest. Then the median, which we're going to call capital M, of the ordered group is the middle value. Okay, if the number of data values in a data set is odd, then the median is just the middle value, since that's going to split the lower half from the upper half. If the number of data values in a data set is even, then the median is where you take the sum of the middle two values and then divide that by 2. Okay. By the way, when you use the symbol for a median, make sure that is different than the symbol for a mean, okay, for a population mean. Capital M and mu kind of look the same, okay, but one's slanted and one's not, okay. So sometimes when we compute a median, the data value may not be in the data set, and sometimes it will be. Okay, it just depends on if there's an even or an odd number of values. Another definition, the mode of a data set is the value that occurs most frequently. A data set can have no mode, one mode, or more than one mode. Okay, and there's no symbol for the mode also in this book. They just write mode equals and then whatever it is. Okay, a data set may not have a mode. Okay, if there's no repetition of values, then there's no mode. Okay, otherwise, whenever there's repetition going on, there will be a mode that you pick off. Okay, there's a note there saying that the variable can be qualitative or quantitative when we determine the mode from the data. Okay, so if you're just selecting the item that you see more than any other, it doesn't have to be just numbers. You know, it likely will be, okay, but it doesn't have to be. Okay, whereas when you compute the median or the mean, you have to have quantitative values. Okay, so keep that in mind there. Problem 1 says the following data represent the travel time, which is in minutes, to ICC for 24 students in a statistics class. Treat the 24 students as a population. Okay, so there's our 24 names and the 24 times that it takes these individuals to get here in the morning. Part A, compute the population mean, median, and mode. Okay, so to find a population mean, we use the symbol mu, and I need to add up all the numbers here, which should give me 487 as the total when I add up all 24 of these numbers, and then I divide by 24. Okay, that is roughly 20.3 minutes. Okay, so what that means is that on the average, it takes all 24 students in the class about 20.3 minutes to get to ICC here in the morning. Okay, now there's going to be so many times where we're going to have to use the approximation sign, so I just remind you about that again. Please be good about using that symbol. So whenever there's rounding, we must have that symbol. Okay, I see sometimes where students use an equal sign and it should be an approximation sign, and so don't do that. Let's find the median next. Okay, the first thing that I have to do when I compute a median is I need to order the data set from smallest to largest. So okay, here's 4, which is the shortest time listed. Here's 9. There should be 2 11s. Here's 1 and 2. And then there's a 12. Okay. And then there's 13. Okay. And so I'm going to order these 24 numbers that I see listed here from smallest to largest. Now, because there's 24 numbers, 24 is an even number, the median is where I take the average of the middle 2 values. Okay, so the 12th and the 13th numbers, when I add them together and divide by 2, so 18 is the 12th number, 19 is the 13th number, add them together and divide by 2, I get exactly 18 and a half minutes, okay, for the median. The mode of the data set is the value that occurs most frequently. So I will have a mode. Let's see here. There's 17 minutes. Here's 1, 2, and 3 times that I see 17 minutes listed. Now, I didn't see any other value listed 3 times or more. So this is only going to have one mode. And I just write 17 minutes. Okay, now suppose that I have another value where it says 22 minutes. Okay, and so I got 25 students, let's say, and at 22 minutes is the time listed. Then I would have a bimodal data set, and I would just write the 2 modes, 17 and 22. Okay. Part B says to find a simple random sample of size 6 and compute the sample mean. Okay, is this an overestimate or an underestimate of the population mean? Okay, we talked about how to find to use a random number generator in your calculator. Okay, and so here I've got the 84. Okay, and again, if I hit turn the calculator on, hit math, and then go over to PRB, then down to number 5, rand int, and 1 comma, I've got 24 numbers listed, and hit enter. Okay, and so it gives me a random number between 1 and 24. Okay, so suppose that I do this, and suppose that the first random number is the number 5. Okay, now you can use the original distribution or the ordered distribution. Either one is fine. Just make sure that you're using the same one when you gather all 5. Okay, so the 5th number that's listed here would be the first number in the data set. So suppose, I hit enter and the number 5 comes up. Then that would mean that 12 would be the first number in the data set. Okay, suppose I hit enter again and the number 15 comes up. So here's 12, 13, 14, 15. The 15th number is 21. Okay, so 21 would be the next number that I list. And then suppose I hit enter again and the number 8 comes up. Okay, so the 8th number listed is 17 minutes. Okay, so that'd be the next one. Suppose that the number 4 comes up on the screen. So the 4th number is the number 11. And suppose I hit enter again, the number 18 comes up on the screen. So I got 18 listed. The 18th number should be what? Here's 12, 13, 14, 15, 16, 17, 18, 23 minutes. Okay, and then I hit enter one more time, and I get the number 9 to show up. Okay, so the 9th number listed is 17. Okay, so this group of 6 would be my number, my simple random sample of size 6, and I want to use that to find the sample mean. Okay, so whether it's a population or a sample, the procedure, it doesn't matter. I still add up the numbers and divide by the total. So if I take 12 plus 21 plus 17 plus 11 plus 23 plus 17, I get 101, and then divide that by 6. 101 divided by 6 should be roughly 16.8 minutes. Okay, if I go nearest one digit. So that would be the value of the sample mean. Okay, now the follow-up question, is this an overestimate or an underestimate of the population mean? Well, this would be an underestimate because the true average that it takes all 24 students to get here in the morning is 20.3 minutes. So we got 16.8 in our selection of 6. Okay, so we underestimated the true average. Okay, we underestimated by 3.5 minutes, and so I guess that's it's not a lousy sample, although it's not great. Okay. There's just some things that you want to be aware of when you go out and get a sample. Now, what if instead of selecting 6 numbers, I select 16 numbers? What ideally should happen to this number here compared to this number? Well, this number should get closer to this number. It should. Okay, so if I'm not going to do that, but that's one of the underlying fundamentals of statistics. The more information in front of you, the better. Okay, so I'd like it if I could use more values if possible. Okay, I've got a note here saying that numbers do not equal other numbers. Okay, so here's a good example of sometimes where I see that. So suppose I want to find the mean. Okay, so I take 12 plus 21 plus 17 plus 11 plus 23 plus 17, and I get 101. And then I'm going to divide that by 6. 101 divided by 6 is 16.8. roughly. Now, if a student wrote this down, that's actually a major problem. And, in class, I would take points off of that. Why is that? What's the problem with that? Well, so what they have written is they're saying 12 plus 21 plus 17 plus 11 plus 23 plus 17. That's approximately 16.8. No, it's not. It's 101, right? So I guess the point that I'm trying to make here is don't get carried away with the equal sign. I see that sometimes, and that's bad, okay? So the mistake here would be this sign. Don't use that, okay? Unless these are equal, okay? These two sides are not equal, okay? So for us to use the equal sign, that'd be bad, okay? Just make sure that you're good about that. So, okay, let's go ahead and we'll stop right here in the notes, and I'll pick up with this then next time. Then problem 2.